Hi, my name is Tochiko Zurumba. I'm a software engineer at Move Forward, and today I'll be sharing with us how we were able to create a virtual private cloud that was only accessible via a static IP. But before I continue, I would like to talk to us about Move Forward. So Move Forward, we actually focus on it's providing high efficient applications that integrate teams with a whole lot of Atlassian products like Jira, Confluence, GitHub, Microsoft, and the rest of them. We've been able to provide high customer support for a whole lot of businesses like Apple, SpaceX, Microsoft, LaunchDark, and the likes of them. And our full aim is to help software teams improve their productivity, increase visibility by integrating different collaboration tools. Thereabout, you don't have to think too much. You have you have teams being integrated to software departments like the human resource department, like your product management department, and the likes of them. And our aim is to truly move your work forward. So talking about our major tool, we make use of serverless, because before we actually did this, before we had a lot of challenges managing our cloud applications in different environmental scale. So to make enable that, we actually decided to use serverless. And serverless, like we all know, helps on a general level to eliminate a whole lot of infrastructural costs or maintenance or cloud provisioning. With the help of serverless, we're able to get a whole lot of our AWS services running with little or no additional cost. And it helps us to automate and simplify our deployment processes. So everything's actually really simple and straightforward. Everybody can actually try it. Even you can actually do it too, right? So you can go over to serverless and read more and get more understanding about how serverless works. Now, the solution in mind. So the aim was to secure our application and to ensure that it's only accessible through or via a static IPs. The static IPs are actually provisioned by AWS Global Accelerator. You can actually read more of that. It's actually a good tool. With static IPs, they are being mapped to a custom domain, which is provided by the Route 53 and secured with Certificate Manager to ensure at least we are not hacked by anybody. Now, whenever you go through the domains, it reserves to our static IPs, which gives you access to application load balancers. The load balancers manage the health and the strength of each of these applications to ensure that you actually get the best out of it. And these load balancers communicate with the application via a VPC endpoint. Now, a VPC endpoint enables some of AWS services to be able to communicate with any of the resource that is being provisioned by a VPC cloud. So our applications are being deployed within the VPC, and then they have been provisioned by our AWS API gateway, and they can only be accessed via a VPC endpoint. So without a VPC endpoint, no other of AWS services can actually communicate with our application, of which it's actually very important. So the VPC net endpoint is actually very important to enable this connection. So, and for us to be able to do all of this, initially, we've deployed our applications in serverless, which we are using an edge-optimized API gateway. Serverless helps us to deploy applications to a cloud distribution. These cloud distributions are provisioned or are accessible via the API gateway. And then we have a custom domain that is being provided also by serverless to actually help us to help anybody to actually access those APIs. But to actually help us to do what we need to do, to help us to procure a VPC resource whereby we deploy applications within this VPC resource and we make it accessible, for anybody through those static IPs. We needed to actually reconfigure our architecture. And since we already had serverless running already, it would cost us a whole lot to actually eliminate serverless entirely, because we needed to actually have the Terraform deployments. We needed to have Terraform deploy our VPCs and all other resources. So we decided to go with this three-way deployment. This three-way deployment consists of the first one, which is where we actually provision all of the VPC resources like the VPC IDs, the public and private subnets, route tables, security groups, NAT gateways and internet gateways to give internet access to our VPC resource. So as our VPC is being created and being made ready for use, we go ahead to now deploy our serverless deployment. Our serverless deployment, it would now be converted now from an edge optimized gateway to a private endpoint type. And if you can see that we already make use of our region, which we've deployed all of our services on the US East 1 region, and then it's now accessible via a VPC endpoint, like I mentioned earlier. The VPC endpoint gives access. Now, the VPC endpoint executes API means that our applications are given right permissions or full access to execute any of the APIs within the application from outside. So any of the AWS services that has access to this permission has a full right to actually execute any of our APIs within the application or within the VPC. And there is also a resource policy. You cannot have a private network without giving rules to watch how any of the application is being executed from outside the VPC. So the resource policy gives us those access. Now, this resource policies works in a synchronized manner, whereby it's more like our if-else conditions, whereby you have to actually go through the first one before you go to the second one. From the first rule statement states that you cannot, which is the effect, this is the action denial, you cannot access the application if, and this is the condition here, if you do not have access to the VPC. So without you having access to that VPC or without up to that private network, you do not have access to actually execute any of those API. But if you have access to the VPC, then you are not allowed to execute the APIs within the application. So it's actually a very simple rule. If you do not have access to the VPC, sorry, you don't have access to actually execute any API. And the only way you can have access to the VPC is via the VPC endpoint IDs. So the VPC endpoint execute API gives you access or right access, gives you the VPC identity, let's give it like that, to be able to access or run any applications within a virtual network. Then after we're done with our serverless deployment, we go ahead to now finalize everything, because at this point in time, our serverless has enabled us to deploy all of our resources within the VPC. You can only go through those VPC endpoints to be able to have access to the application. And then over here now, it's now the last part where we now provision other resources like our application load balancers, application global accelerators, the Route 53, which is the custom domains, and then the SSL needed, which is your certificate. So with the last deployment, we're actually providing those other resources, and we're mapping them to the API gateway that was created with serverless. And it's a full flow from the VPC, from Terraform deploying the VPC to serverless deploying your APIs and your application, to the last global Terraform deployment, whereby we now finalize all of that has been deployed and ensure that it's only been accessed via the static IPs. So from the previous code, this is more like a much more explanation. We converted our edge optimized API to a private API endpoint. And like I said earlier, you cannot actually associate your VPC with a public API. It has to be private, because that's the only way it can be really secured. We attached our VPC endpoints. This endpoints has given AWS services the right access to actually access anything within the VPC, and they've restricted our API through the VPC endpoint, through static IPs, and through the custom domains that are associated with those static IPs. So that's how the flow goes. Now, why serverless? What are the technical benefits of using serverless? Like I've mentioned, like I keep saying, you can actually go check what serverless does. Serverless has enabled a whole of simple and automated deployments, with as much as a simple code or a simple command line, you can get your app fully deployed, up and running. It has taken the whole of operational or infrastructural maintenance, and every of those responsibilities has given to AWS to actually assist you in managing and maintaining plus deploying your application. How does it help your team with velocity and flexibility? Trust me, with serverless doing that whole lot of work, you really have a lot of speed. With little or no information about what DevOps entails, you can actually still use serverless to actually deploy your application. It's really fast. It's easy to actually communicate those ideas or those knowledge with your new team members, and it's very flexible. It's easily provided once, every time now, every now and then. So what are the business benefits? Did it save you significant money on time? Yes, I didn't have to spend so much time trying to train anyone how to actually make use of serverless. It's actually pretty straightforward with one command line. So far, you have your infrastructure. You have your infrastructure well written with the right template and right information based on what you want to do. It's pretty straightforward towards how you can actually deploy, and we've saved time, money, because the infrastructure management became very simple, and everybody in the team can actually do it. So everybody can actually do it. Even you're listening, you can actually go over there, see it for yourself, and it's pretty easy to catch up. Yep. Were there other alternatives? Yes. Terraform. So we already know how vast Terraform goes. Terraform can provide a whole lot of other resources, can provide for Azure deployment, can also provide for Google Cloud deployment, as well as AWS resources, right? But the reason why we are so sticking to serverless was, how simple serverless is. It's way more simpler to use than Terraform. Terraform, you need to have a certification, at least close to having a certification to actually have a much idea on how to actually use it. So you really need to spend a lot of time learning how to use Terraform. There's a downtime risks. Since we already had a serverless deployment on ground, rather than going ahead to do a whole new thing that would risk us a whole lot of uncertainties, a whole lot of costs, still try to retain our serverless deployment and serverless architecture infrastructure was probably still one of the best things that we could think of. Not enough time to write a new Terraform setup. Yes, there wasn't really enough time for that because it's going to cost us more to do that. And serverless makes our deployment simple and straightforward. So, yep, you have it. The results. So, in conclusion, what were the final results for using serverless? What's in store for the future of the company? So we've already helped thousands of companies and millions of users, and we are really planning to extend our hands. So like I showed us earlier, most of our deployments are within the US East 1 region. We have plans of actually going multi-region, going to other regions like Canada Central, African South, Australia, Europe, and the likes, so I can actually reach out to as much more businesses, as much more users, to ensure we are assisting them as much as possible to move work forward. The key results were like with serverless, we're able to convert our edge optimized APIs to a private APIs with a one simple call. a few changes here and there. Seamlessly integrate VPC endpoints and resource policies to API gateways to ensure that they are only restricted people who have access to this VPC can actually, have access to our application. And our application is more secured as it could be. It's because now it was previously in a public environment. Now it's within a private environment where you can only access it via those static IPs, or if you have access via VPC. And how do you have access to the VPC? It's still via the static IPs, and these are routed via the VPC endpoint. So in other words, we've been able to get that security we're looking for. We're able to give our customers much more assurance that wherever information they are passing within themselves are actually secured, and it's gonna we are looking forward to to building more trust within our applications and our customers out there. So like I said earlier, our job here at Move Forward is to ensure we are moving your work forward. We look forward to more other I look forward to more other resources where we'll be communicating more of what we do here moving forward. At the end of this video, I'll be dropping a link where there's more information about all that's been discussed, how we're able to make those connections from our Terraform deployments of VPCs to the serverless deployments down to the other set of other deployments we have out there. Thank you very much for listening. I'm pretty sure that you've learned a lot, and I'm pretty sure you're curious about how this is done. It's really simple. Go through those links, get more understanding. I wish you luck. Thank you very much for moving forward.